In this part, actually, we are going to see the as we continue reviewing the utilities or the tools responsible for accomplishing the investigation and the forensics. We are going to discuss from an abstract view the need to specific tools, software and hardware tools to accomplish the investigation or accomplish the forensics task, or what are the needs means. And we see the forensics software responsible for accomplishing different investigation tools, hardware also responsible for accomplishing investigations in plural, and because actually the commercialized tools and the also commercialized hardware, software and hardware, both available on the market for accomplishing different investigation plans. They are not all valid for all the, let's say, specifically and more precisely, the official investigations. So the validation of those tools is one of the concerns. So we talk about the needs. What are the needs that push us to use this or that, whether this software or the other one, whether this hardware or the other one, and so on. The requirements in the sense, and the software responsible for doing the logical investigations, logical approaches. Logical means in the sense of software, yeah, computer programs. Hardware, the equipment, the devices, the responsible physical peripherals needed to accomplish the investigation whenever needed. Then after validation, starting with the needs actually, usually as per the continuation of the last unit, which is the working with the Windows and the DOS. Still, we talk about a framework where we have to start with a main framework where we can have a user-friendly utilities. What does it mean? It means actually we need to start with an operating system, usually an environment where we are going to do a digital forensics or digital investigation. There has to be actually an operating system running, and we have to use a compatible operating system to the environment, because some cases we find only the storage devices, storage peripherals that we need to investigate as investigators, because the original operating system is damaged or crashed or something like that. It's not operating. So we need to have a compatible operating system for reasons to retrieve as much as knowledge from the original platform, since it is compatible. So here we are not defining the operating system, but we are presenting the operating system because we cannot start without the operating system. It's the first layer on top of the physical layer. It's on top of the kernel, the physical layer. We find the operating system. It's not the tool we use, but on top of which we are going to use the tools. So there have to be actually some of the descriptions that specifies what are the tools. I was just defining the operating system, that it has to be compatible with the environment where the investigation has to start. Why? Because it is the key to specify that we are able to extract as much as data we can, because we can run actually on top of an, for example, mobile device, Android. We can run a very up-to-date operating system and neglect what are the specificities of the hardware, and it will run. Here, no, it's not the case. We have to be very precautious. Why? Because we need every and each single small piece of data that can actually lead to an answer to one or many questions within the investigation. So the context of the flexibility and the robustness of the environment or the framework. It is a scenario via which we will be able to move from a utility to another, an appliance to another, and storage device to another, from a computer to another, and so on. So there have to be actually a consideration of those points in order to specify, yes, we need, and yes, we acquire this tool or not. This is actually an abstract presentation. Technically, we talk about the operating system. That has to be actually one of the questions. We cannot run an operating system which is, for example, Windows-based on top of a machine that it is conceived to run only Unix-based or Linux-based. Operating system, for example, Windows 10 will not run on a Mac device, which is on top of a Linux operating system. There are restrictions. And if we try to do so, we may succeed, yes, but will we be able to succeed in our investigation? I doubt so, because the trial to match the Windows 10 operating system on top of a Macintosh device hardware, it will lead us to, let me use the word, play on the file system of the storage device where the operating system would be installed. And this is actually, we are going to cause the evidences to be lost. Manually, we'll do that. We'll destroy the evidences. So it's not what we want. It's not the option. It's not the best behavior. Thus, the file system is one of the considerations also. Why? Because if we can run the operating system on the machine, does not mean that it is one of the operating system we can choose. No, we can run Windows 10 on a Macintosh device. Yes, we can install it, but we destroy our key actor to extract evidences. So to extract evidences, one of the very famous actors, and we define that at chapter number 4, the file system. Chapter number 5, sorry. The file system. If we destroy or if we modify or if we change the nature of this file system, we are losing evidences in plural even. And this is actually not only to lose some evidences, we may lose the totality of the evidences available in our environment where the investigation is being run. Other features via which we choose, we may specify that we need specific tools, is that we need to, for example, write some commands. Like when we talk about the MS-DOS, we need this a command prompt interface via which we write commands to do a deep analysis. PowerShell, for example. Those are Windows-based. Terminal using the Linux or Unix. Terminal also using the Macintosh devices. So we might need a specific tool, whether it is a hardware or software, because of the capability to pass commands. We need commands to be passed for a specific investigation. To accomplish our investigation, we need the CLI, command line interface. Also, because of the size of the investigation, we might need an automation, because not in all cases we are going to investigate one device or two devices only. We might investigate, or investigators might investigate a full network. Like, for example, here inside the University of Lindsay, we have thousands of devices. How much time we need to accomplish the investigation of each device? Days, weeks, months, years even, maybe? Yes, absolutely, it can. The number is huge to consider. If, for example, on computer we need from us 3 or 4 days to accomplish the investigation, how much time we need to accomplish, for example, as per the last number I know, actually, 1,500 devices in our campus here. Desk devices only. We don't talk about the laptops and other beyond bring your own devices available in the available inside the network and connected to the network. We need more than years, with long time. So we need automation, generation of templates, and the automation in order to facilitate the task. So the utilities we need to use, they have to provide or to run with an automated plan. Yes, we need them like that. We need them with this feature. And they have to be trustworthy. We were discussing actually earlier that Not all the available tools, they are actually compatible to what we need. They have to be actually, because we do not have to trust the validity here, the validation. We have to trust the first thing actually we have to consider in order to validate the tool, whether it is hardware or software, is that we have to validate the vendor, the brand, who is the creator of the tool, because some of the tools, they might extract some knowledge and they might also at the same time block others or delete others or obfuscate others. They may retrieve some and destroy others, so they are not trustworthy. So thus we have to trust the tools we use. Tools here means both hard and soft. Then after, I'll go very fast here since the thing is clear right now, so I'm gonna go a little bit faster. For different investigation tasks, remember the hardware is not only a computer. Hardware does not mean we are going to use a desktop computer or a laptop computer or a mobile device. No, it is something to specify based on the crime scenario, crime scene. We discussed that in chapter number 4. So the device to use is not a standardized device that has to be used for all investigation scenes. No, because some of the cases we will need a hard drive reader. Yes, because the hard drive is already damaged. The hard disk, the storage, the main storage memory is damaged. So we need a specific reader to read the content of the storage device. So what is that? It's a specialized and specific tool, hardware. Yeah, used for forensics only. Not only the graphical tools you can use or you can need when we talk about the software, but also you can need the command line interface like the MS-DOS. Not only the graphical tools, we have a long list of graphical tools that we can use whenever we do investigations, but they are not the unique and they are not compatible for all cases and crime scenes. Crime scene. When we talk about the investigation, we said that it is a plan to be set at the beginning, so the investigator has to recognize clearly what to do from the beginning. Actually, this is a context of understanding what the crime scene is, or how it happened and where it happened. Absolutely. So we were not able to standardize so far the behavior of investigation, but we were able to describe what he has to do whenever he is in front of a crime scene. Here in this view now we are able to at least draw the main lines via which the investigator, digital forensic specialist, has to go beyond and after in order to accomplish a case or a digital crime investigation. He has to acquire the knowledge in order to process the crime scene. Where, when, who, what. He has to ask all the questions in order to acquire all the needed data to understand the scenario. After asking a long list of questions and understanding the crime scene, the processing of the crime scene starts from, yes, admitting this, denying this, admitting this, saying, denying this, saying, admitting this data, denying this data, and so on. Validation and discrimination. So he had a long list of data regarding the crime scene, let's say, the digital crime scene, yes. And in order to pass to the next stage, he has to validate and discriminate. Not everything what he heard is true, because of the questions they are, in so many cases, they are presenting conflicting answers. Specifically, if you are asking the same, the investigator is asking the same question to different people with different, let's say, parties, he may find contradictory answers. So he has to validate one and deny one, discriminate one. The resultant data, the resultant admitted data from which he has to extract answers to all questions to clarify the crime scene. And from those answers, he has to be able to, the investigator, he has to be able to build the event, how it happened. Construction here, or reconstruction of the event from the beginning, based on his findings. And then after reporting means to generate the report, whatever he found, what are the phases he passed through, until the why and how he answered the questions related to the crime scene, for sure. Reporting. Hey, any questions, Aya?
No, Mr.
Okay, briefly, acquisition means actually the digital forensics specialist has to impose, I may say, lots of questions to recognize what are the key elements of crime scene, devices, software, data in question, sensitive data used. What are, because actually when we say my computer is hacked, what does it mean my computer is hacked? What does this mean? My computer is hacked. Somebody has opened my computer only, nothing happened. So there is no hack. We cannot talk about a hack. But if I say my data is stolen, still, what is your data? Are they for example, in my case, are they exams? Are they students' marks and grades? Are they actually some research findings? Sensitive data means here the acquisition has to answer those questions, has to clarify that. So there have to be actually a scenario which the investigator has to recognize what are the responsible to clarify the crime scene, and also he has to preserve that, not only to acquire the knowledge, but he has to preserve that. And we discussed the chapter number crime processing the crime scene. When we discussed the processing the crime scene, chapter number 4, we discussed how how the investigators do make actually a copy of the original data, or whatever he has to find. If the computer is running already, he might have actually an entire disk, sorry, just a portion of the content copy. But if the full operating system is damaged and only the hard disk is available, he has to make actually a full and entire drive copy with its all content. Yes. Usually we talk about the assembly as a first view via which we see the data whenever we talk about investigations. Here, this graph, it is demonstrating what a portion of data related to some extracted data, but in an assembly mode. In an assembly mode, seen in hexadecimal. Assembly level seen in hexadecimal, yes. All those numbers here and the other, the extreme right side, alphanumerical values, completely we can calculate, we can generate. completely. We can do and calculate, but it's not our purpose for now. We have to know that we are going to extract processor level data. We're going to extract what the computer sees. And from there, we are going to try to extract the human-friendly values. This is what the computer understands. And this is what the investigation tools would extract. And from here, investigators will try to change the view and extract the graphical views, what to means what the humans can understand. The scenario of the how to copy the data and why we copy, before I dig, I explain how we copy. It is why we copy actually the data, because as I said, I give you the example, the computer is crashed, the computer is not running, so we need to have the original data, the full original data, in order to investigate what happened, the events, step by step and so on. So where we're going to do that, if the computer is crashed, the operating system is crashed, we are not able to recover the same operating system. So what should we do? So we have to make a full copy to the entire hard disk. How to do so? Using specific tools. There are specific tools responsible for, yes, dedicated software responsible for accomplishing the matter of the copy, because we are not going to make copy paste one the hard drive and do a right click copy, right click paste. It's not like that. It does not happen like that, because this matter of right click copy, right click paste, it might cause some sectors to be overcopied, sorry, overwritten, and thus the original data is being lost, which is a failure in the investigation. So the copy paste, it is not a simple right click copy, right click paste. It's not like that. At least it's not the case for the fully damaged operating system case or crime scene. It's not. The second part actually after the acquisition is the validation and discrimination. Yes, all what he drawn as a framework to clarify the view of the crime scene. He has to validate whatever he needs, and he has to discriminate whatever he does not need. And the discrimination is not only because he does not need, but in some scenarios because he does not trust the value. Some questions, some answers, they are not trustworthy. He does not trust, so he may discriminate, he may eliminate. Who? The investigator, we thought. From there only, here, from this context of the validation discrimination, investigator will be able to extract and, yes, redraw the crime scene. Yes. And later on, there will be actually a validation to happen. But the validation here, we see it, it's the validation of the what we have to validate and discriminate. The investigator has to validate, yes, this answer is good, I trust. Oh, no, this answer I don't trust, this answer I trust, this answer I don't trust, and so on. It's not because of his understanding only. No. He might be an expert in the field, and we might trust his answers and his findings in so many cases, yes, but not all technical values to be trusted by just a sight, a look by an eye. Even if the investigator is expert, even still, we do not trust in technical cases. We do not trust the overview, the simple view from an eye. We talk about an expert, but even though it's not the case that we can trust. Presenting the example of the hashing, whenever values they are presented in a hash value, in a hash format, whomever the expert is, he might not have the chance to validate that this hash value is for a certain textual, let's say textual value or something like that. Hash value is not something that we can actually decrypt. Reverse engineering is failing in doing the task versus the hash values. Hash values, they are not reversible. Thus, there have to be a validation mechanism, which is to hash values to match them, to validate, whether to accept or to deny, to discriminate. So there have to be a matching, a validation. And this validation does not mean that the investigator has to do the full calculation from the beginning. There are scenarios via which investigators refer to the available libraries presenting standardized hashes for different, let's say, key entries. Here we talk about the National Software Reference Library. It's one of the libraries that stores standardized, let's say, known hashes to be utilized in investigations. Then actually the investigator might make matches with those hashes. If matched, so he knows the value, the original value. Example of a software. One of the consideration here also is that whenever we validate the validation and the discrimination, is that values might have headers, not only the content body. What does mean? It means the tools used in for example in an attack or in a crime or whatever, they might leave a trace which is the definition of the tool. We do not in all cases, for example, if we want to make an investigation to retrieve only, to recover deleted value, the value is not the tool used to process the crime, for example. No, the data is the data and the tool is the tool. So headers and definitions of the tool is not required in all cases to validate what to validate or what to discriminate. Whatever. Notifications. Dedicated forensics tools. The meaning of extraction means we are going to the investigators are going to recover the necessary values from the storage device, storage mechanism. Extraction is the one or the number one actually forensics behavior investigation has to do. They have to be very skilled and very fast and very accurate and punctual whenever they talk about extraction, because the data extraction, not only information extraction, data extraction is one of the crucial points via which investigators they can solve and stand on to solve crime issues, crime scenes, because it's the first step, yes, and it's the primordial and the very important step to finalize the crime scene. Irrespective, there are tools for extraction dedicated to extraction only. After the extraction and the discrimination, we talk about the reconstruction. It means to draw back the full image of the value or the crime scene or the event or whatever. Reconstruct. Taking the example of the fully damaged, because to clarify only, because this is not the unique case. We take the example of the fully damaged hard drive or a fully damaged computer. The operating system is no longer running. What should we do? The investigators will fail. No. still we have the hard drive, the physical device. Investigators can use to make a disk-to-disk copy. They may actually make also another image-to-disk copy. Here, disk-to-disk means means they are going to copy the data only. Image-to-disk, even the file system is going to be copied. The file system, even from the original media, will be copied fully. The content with the file system. Partition to partition means actually we're going to talk about a drive to be copied to another drive, from a drive to another. Image to partition, we are going to compress somehow the file system plus the data itself into a segment or partition in any environment. Reconstruction. Tools that we can be utilized to actually. The one described in our book is the ProDiscover, is very famous with us. ProDiscover. Tools, yes, tools for accomplishing this reconstruction. Finally, the investigators have to generate their reports. Investigators have to generate their reports in order to say that yes, we validated and our investigation is terminated. Okay, crime scene is being solved. They might not find proofs, but they have to report that they did not find proofs because no proofs are there in the crime scene. Not only because they do not know how to, no, but because there is no proofs to extract. Maybe, yes, it depends. But once any report is generated with a confirmation of crime scene, there have to be actually an extraction of proofs and the validation with the proofs. The report has to cover the events, what happened, plus the logs of the events, when and where. These want to generate actually a final report. Validating the tools, whether to use this or to use the other. It is not based on my understanding only because Murad knows this, so khalas, we use this. No, it's not like that. Validation of a tool to be used in forensics is if he is capable to do a lot of, or to present a compatibility with a lot of the functions required to investigate, starting from the physical and logical environments, we need software that is compatible with a certain and specific file system and certain specific operating system and hardware also. For example, here we talk. The outcome of the software has to be in a specific format, and so on. So those are actually criterions via which we, graphic and command line, those are criteria via which we validate, or investigators validate whether to admit a specific tool or not. All the others, actually, all what it remains is to validate, to describe those validation criterions. Any questions, Aya?
No, Mr.
Let me see your answer and